Hello, class of Math 103. I tried to create a couple of short videos on how to use the technology for this unit project. So let's look at our studio first. So this project has to do with, we want to first estimate the proportion of people who text while driving, who text while driving. So, and each one of you get your own personalized data set. So first we're going to estimate it, and second, we're going to check a claim, whether less than half of the population had sent a text message. So in order to do that, as you have the instruction based on your self ID, you can select the data set. So let's say I have 99, which nobody has 99, so I can use that as a sample. As you see, the data set has two columns. It has the ID number of the participant, also has text while driving. Now, if you look at the descriptions that you have, one indicates they said, yes, I text while driving, and two indicates no, they said no, they don't text while driving. So what we want to estimate first is the proportion of people who text while driving. So the proportion of one in this data set. Now, the sample is small enough, we can actually count how many ones we have. So if you count the number of ones here that they text while driving, I have, let's say, around 11 who said yes. Well, a lot of time, if you have large sample size, you want to upload the data, download it to your computer, upload it into AutoStat or RStudio and do the analysis. So let's go to RStudio. If you plug in rstudio.cloud, it brings you here. Click on login. And I want to log in with my Google. All right, let me use my generic Gmail account. All right, let's do unit projects. Yes, depends on the server. It might take a little bit of time to upload the project. All right, let's get it perfect. Now, the nice thing with Canvas, if you click on the file, it opens it up so you can see. All right, I'm going to move this a little bit here. I have many files open. Let me go here and let me go down here. So we are doing, if you do double pound, you just leave a note for yourself, unit 6 and 7 project. So in order to estimate the proportion, let's type PR. So proportion PROP. So right away you see it says proportion test. We want to use this one, and it gives you the moment you click or you enter it, it gives you the options. So if you click between these two and click on tab, it gives you X is the number of success. So I had 11 people who said yes. Do comma, then do another tab. It says, what is your sample size? So N, in our case, was 30. What else? We want to do confidence interval. So we go here. If you don't choose a confidence level, the default is 95%. But let me choose one. 95% means 0.95. And if I run this command, at the bottom, you see it says one sample proportion test with continuity correction. So 11 out of 30, we have the 95% confidence interval, which is for this sample 0.20 to 0.560. And the p hat is 0.3666 or 0.37. Now let's say that's the first part of this project. Now you want to test the claim. So we do PRO, I click tab, so prop, and give us the test. And number of success, we have 11. You don't have to put, you can just plug in 30. You don't have to plug in n equal to. Now here, if you do comma, then it gives you the options. P is very much the null hypothesis. Now in this question, the second part says more than half. So more than half means alternative claim is more than 50%. So that means we assume the P, the population proportion is 50%. And if you click, the alternative is we want it to be to be less than. So if you go back to the project quickly, it says less than half. So the P hat is 50. Click tab. We want the alternative to be less than. We click here. Anywhere on this line, you don't have to click here. You can, as long as it's on that line, you run the command. There we go. Now it give us a p-value of 0.1006, which using the 5% as a threshold, as a, if you go here, I believe I gave you 5%. Yes, if you use a significant level of 5%, this is not likely. This is likely to happen because 5%, anything less than 5% is very unlikely to become a statistically significant. But here is 0.1006, which is more than 5%, so it is likely to happen. That means we failed to reject the null hypothesis in this case, which means is not less than 50%. And it kind of makes sense in the confidence interval also, because they should both confirm each other. In most data sets, there are a few that there might be contradictions that people might have. So these two commands would help with our study. All right. Please email me if you have any questions.